All right, welcome ladies and gentlemen to the Forge track. We've got a set of pretty awesome sessions today, all from engineers and designers and product managers who are actively working on the Forge project. So they've been slammed over the last few weeks on the execution side of things, trying to get Forge out the door and getting the labs experience set up for camp, and simultaneously putting together some great content for you all to see how we're thinking about Forge and what sorts of capabilities we're building for the future. So first up, we have Pete Gleeson, who is the user experience feature lead for Forge UI. So his team have built all of the user experience within the runtime for building out Forge UI components and binding those to Forge functions. So can I get a big hand for Pete, as he's got a pretty cool session for us today.
Thanks, Tim. Magic moments while programming. The first time you wrote code and it worked. When an idea flickers to life for the first time. What about a tool that does in a number of seconds what previously took you hours? Or a framework that just completely knocks your socks off? When was your last magic moment while programming? For me, these elusive moments are what keep me obsessed with programming. My name is Pete. I'm an engineer at Atlassian, and I'm the dev experience lead on Forge UI. Our ambition for the dev experience of Forge UI is to be packed with these magic moments. Now, we know building something such as this doesn't happen by magic, so I'm here today to share with you some of the cool features of Forge UI while we build an editor app. An editor macro, I should say. First, we'll introduce Forge UI and have a look at what editor macros are. Then, for the bulk of the session, we'll get hands-on and build an editor macro, introducing some of the concepts of Forge UI along the way. Finally, we'll have a peek at some of the future directions we can take Forge UI in. Forge UI is a declarative way of building UI inside Atlassian products. It's declarative in the sense that you specify the what rather than the how. This is akin to something like HTML, where you say, I would like an input tag here, and then that's the what. And the browser takes that tag and interprets that so it creates something that looks like a text box and behaves like a text box. That's the how. This declarative style is a very good fit for Forge UI because it means we can have a common cross-platform format. You can say, I would like a button, you describe that, and then we can take that button, and if your app is being rendered on web, turn it into an Atlas Kit button using React, or if your app is being rendered on iOS, we can render that button natively using MobileKit. Because this implementation is completely handled by the platform, we don't need any web views or iframes. This is going to be a massive usability boost because we don't need to wait around for things to download or for web views to start up inside our mobile products. Another main point that I really want to hammer home here is that your app moves as our platform moves because the implementation lives in our platforms. By this, I mean that if a product upgrades Atlas Kit components, your app will receive those upgrades. It will be using the latest version of Atlas Kit components. Something even more exciting, though, if an app is on a page that gets server-side rendered, well, then your app is server-side rendered. This would mean that we can give a meaningful paint to the user faster than we've ever been able to do before. Now, this is our code editor. This is the Atlassian editor. It's a cross-product editor, and it's the thing you use to create Confluence pages, make comments on Jira issues, or comments on Bitbucket pull requests. This is the first place that we're showing Forge UI. It's the first application of the Forge UI technology. In this drop-down here, macros, and with Forge UI, your app will get a spot in this dropdown. We think editor macros are a really good first spot for Forge UI because, as I mentioned, it is cross-product. There is potential for you to describe your app once, and that's a cross-platform description, working inside a cross-product component. So the bang for your buck here is potentially massive. We also know that in Server, macros made Confluence such a popular product as it is today. We know that teams have multiple macros, and they really tailor or suit their team's workflow with those macros. So we're happy to be bringing some of the power back to our cloud offering with Forge UI. Here is how some of the pieces that I mentioned hang together in broad strokes. We have the editor that's inside Confluence, and then when your app is requested, we send an event to get what your app should look like from our FaaS infrastructure. That will run your function, which has Forge UI running inside of it. Forge UI then returns a description of your app to Confluence that is then implements your app. So we just introduced Forge UI and why we think a declarative style is a really good fit for this problem space. We talked about editor macros and we're excited to bring Forge UI there. Next, we're going to get hands-on and build one of these things. We'll build a counter app, and then we'll have a look at an app that I've prepared earlier and have a look at some of the more advanced concepts in Forge UI. Your first point of contact with Forge is going to be through the CLI. Now, I've already logged in and set up a dev instance, so I'll start by creating an app. You'll be prompted for the name of your app. Then you'll be prompted to select a template. Now, these range in how opinionated they are. The blank template comes with almost nothing, and you're free to bring the technology and make your own choices about how you build your apps or Forge functions. Whereas Hello World, for example, comes with TypeScript and ESLint and, crucially, Forge UI. And this, at the moment, represents kind of the best practices for building these apps. We'll select this for our purposes today. At this point, we're creating an app, and it's being associated with your Atlassian ID. After that's done, we're then cloning the repo and putting it onto your file system. Let's take a look at some of the files we have here. The first thing we'll take a look at is this manifest file. Now, this is the thing that describes what your app does. I kind of think of Forge apps as a sum of their modules. So if you can imagine you're building a Forge app, it might have a bit of UI, it might have a webhook or a product event. And so you would have these modules listed in this manifest here. What we're interested in is this macro entry. This says that this app is going to need a place inside the Confluence editor. Now we're going to build a counter app, so let's change this to be something more descriptive. I think I've practiced this talk enough to consider myself a bit of a connoisseur of counter applications, so rest assured you're in safe hands today. We're going to build a good one. Before we have a look at some of these other files, let's just deploy this and see this running on a site. We'll install our dependencies first. Then we'll run this deploy command. This is doing a few things. It's taking the files that we have written this in TypeScript, so it needs to transpile that back to JavaScript, a version of JavaScript that's compatible with our FaaS infrastructure, and then bundle that up into a single file. After it's got that file, it then is taking that and uploading that into our FaaS infrastructure. The next step here is to take that deployment that we've just uploaded and associate that with the site. For that, we'll run the install command. We're building a macro, so we'll pick Confluence here, and we'll add my site URL. You'll be prompted to authorize here. I'm actually going to skip this step. We'll circle back and see how authorization works in a minute. So there we go. We've installed our app. Let's take a look at it in the site. I'll remember to refresh my page as well. All right. So now when we type /, we'll look for counter, and there is our app. Let's insert this. And this is the hello world for Forge UI. So our hope is that this is one of those magic moments that I touched on at the beginning of this talk. We have something running on a production instance with 3 commands and in a number of minutes. This is something that we're really proud of, and I hope everyone here will enjoy. Next, let's have a look at how we describe this UI. How have we said that this should say hello world and that text there? This is found in this index TSX file. And there's a little bit going on here, so we'll break this down. The first thing that's probably sticking out at you is we're using JSX. JSX is a great way of representing structured data, and so we're using it here to describe components. These components are coming from this Atlassian Forge UI library. Among other things, this library provides a set of primitive components. You can imagine these like in HTML, you have div tags and p tags and things like this. The primitives of Forge UI are text components, buttons, forms, these types of things. We'll see more examples as we move along. The next thing to point out is that we have written a custom component here, this app component. And this is part of the power of the component model and why we really love the component model at Atlassian. We've made an abstraction with this component on top of these other 2 text components here. Component composability is a massive reason why we chose this model. I can pick this app component up and render that elsewhere, or even publish this on NPM, and someone else writing a Forge app could take this and render it. So this is something that's really powerful, and we're really happy that we were able to have this model inside Forge UI. The final thing to point out here is the render function. Now, there's lots of juicy technical detail about how this works, but for now, just imagine that this is something that takes your app as described in the component model and makes it compatible with our FaaS infrastructure. Remember that this is all running server-side inside a Lambda function. So this is the magic step that makes that work. Next, let's take a look at the dev loop. To do this, you need to run 2 commands. We'll run the watch command. This is something that's going to watch my files and then rebundle them every time I make a change. The second command is a tunnel command. Now, this is a very interesting command. It takes, instead of, when your app is requested from Confluence, instead of serving the files that we've uploaded or we've deployed, this is going to point to the files that we have sitting on our file system. This gives you a really nice local dev experience, as we'll see. Let's change this to a more localized greeting. Change back to our Confluence page and refresh. Great. So this is a very tight dev loop, and it's something that we're very proud of. To the task at hand, we're building the greatest counter app in the world. And to do this, you're going to need a button, and we'll render that underneath the text, this text component here. The text component will show the current count, and when you click on the button, we'll increment that. You'll notice when I try and render a button like this, I have some red squigglies underneath button. This is TypeScript saying that we haven't provided enough props to render this component. It's saying that we're missing the text and on-click props. This is part of the reason why we've made these technology choices. The feedback loop that we're getting from this is really immediate. We haven't had to wait to build the app, refresh the page, and then see a runtime error. We're seeing this problem inside our IDE. We'll fix this up. And I'll just put an empty function inside onClick for now. This is the text component that's going to show the current count, so let's set this up a little bit. And now we've arrived at another crucial feature that the library has. We need to represent the state of our count. And there's some interesting conflict here between a FaaS model where your function runs, and then after it's finished, it's as if it hadn't happened, right? It's disappeared into the ether. Whereas a UI is more persistent than that. It hangs around so long as the user is looking at the UI. So to reconcile this difference, we've provided a common solution inside the library to manage state. So we've imported this function called useAction. And now if you're familiar with React, this is a hook. It's not a React hook, it's a Forge UI hook. If you're not fully familiar with React, that's completely fine. We're going to walk through how this works. We're going to use this function to represent the state of our counter. Now you call this function, the first argument you call it with is a function that runs when your state changes. That function gets passed your current state. So for us, it's our current count. And it also gets passed any arguments you want to make that state change with, which will be, we'll call this function with by how much we want to increment the counter step. You're expected to return your next state from this function here. For us, that'll be current count plus step. And the final argument here is your initial state. We'll kick the counter off at 0. We'll add a little type annotation here to please TypeScript. Now, this function returns an array, and the array has 2 elements inside of it. The first element is your current state. It's going to be count. And the second element here is a function that you call when you want your state to change. We'll call it setCount. At this point, we've set up this hook to represent the current state of our counter. We're pretty big fans of this approach because with hooks, they keep state encapsulated inside a component. And that just kind of reinforces that component model benefit of having composable components. The other thing is that it's very concise, right? The only boilerplate we've really written here is this useAction function. All the other code on these lines relates to the problem at hand. The next part is to just wire this stuff together. We'll put the current count into this text box, or into this text field rather. And then when we click on the button, we're going to change our count to be 1 more. Looks all right so far. There we go. This might be some of my best work yet. So I'll briefly touch on what's going on here. I won't try and steal too much of Michael and Simon's thunder. They're going to go on a very deep dive, and I would highly recommend going to their talk this afternoon. So I've changed this diagram around slightly. I've just kind of simplified the FaaS thing to be just Forge UI in this circle. Now what's happening here is Confluence is waking up. It's realizing that there's an app on the page. It's going to call out to our infrastructure and run Forge UI. It's going to say, what's the description of this app? Forge UI is going to render your app, and it returns a description of that app. But crucially, it also returns the current state of your app, which in our case was the counter. Confluence implements your app and hangs on to your current state. Time passes, and then we click on the button. Now when we run Forge UI again, we send across an event that describes what happened. So that button was clicked on. But we also send across the current state of the app. Using this, Forge UI can kind of rehydrate your app and re-render it, making any state changes it needs to along the way. This returns your next state, which is going to have count be 1. Confluence re-renders your app. We're looking at the number 1 here. It's just so on and so forth here. So I won't try and pretend that this counter app is going to be the secret to your team's productivity, but I hope that you can understand that there's some pretty powerful concepts going on here. Next, we're going to have a look at a more complicated Forge UI app, and then take a look at some of the code that drives that. This is a Jira issue search app that I prepared earlier. It presents you with a drop-down with your list of projects. It prompts you to select a project, and then it'll show the issues for that project inside a dynamic table. This is the code that implements that. It's a little bit more involved, but the concepts remain the same. We have an app component that we're rendering down the bottom of the page. Here we're using another hook that's provided by the library, which gives you information about the environment your app is being rendered into. It gives you stuff like the local ID, the page ID, space key, the user's ID. These are the things you would want to use to make network calls. Below this, we're using useAction again, and this hook represents the list of projects. You'll notice that in our counter example, we had 0 as the initial state. Here we're actually passing in an asynchronous function. The library will run that function, wait for it to finish, and then continue rendering your app. This is a really nice spot to go and fetch any initial data you need. Again here, we're making use of the API that Tim and Joelle showed off this morning. We're making this request on behalf of the user. Let's have a look at how this plays out in the UI. This is an incognito window with me acting as another user. And you'll see here I'm prompted for this app to act on my behalf. As I click through this, I'm taken through the 3.0 flow. I sign my life away, looking at these permissions. And once I refresh this page, I have the same experience that the other user is having. One thing to point out here is that there's actually some persistence going on between page renders. I'm seeing the issues in this dynamic table here, rather than the app completely resetting and presenting me with the drop-down to pick the project from. So there's some persistence going on here, and we'll have a look at how we've implemented that. With these projects, we then plug them into this select box here. That is rendered inside a form. The onSubmit prop, this handler gets called when the form is submitted. And you can also put asynchronous functions in these positions. So you can put asynchronous functions on buttons on click and forms on submit. This is a really nice feature in my mind. It's a really natural place to do network requests or side effects. So using the data that has the project key, we're fetching a list of Jira issues and then calling set issues at this point. We're using whether or not we have issues to conditionally render either the form or this issue table component. Now, this is not a primitive provided by the library. This is, in fact, a custom component. We're able to use TypeScript to describe its prop types, and we're using the table primitives from Forge UI. Here we're taking the issues and mapping them to rows. The last thing to point out here is this use content properties hook. Now, content properties are a feature of Confluence that's basically a key value store that's associated with a piece of content, like a page. We're using this to store the issues that we want to show in the table. This is not a hook that's provided by the library either. This is an abstraction that I've written on top of the tools that are provided. The way this works is that we get the content ID from the product context. We then use action again to, when we call set issues, this function is being run here. We'll get the issues at this, in this variable here, and we post this to Confluence's page properties. For our initial state, we actually want to look up whether we have any value associated with the key. If we do, then we'll return the value that we retrieved. Otherwise, we'll use the initial state or the initial value that's passed in this position here. I think when Forge UI ships, we likely will have some solution for persistence, but this still illustrates that we have quite powerful primitives that you can build your own abstractions on to write features such as this. So we just built a counter app and installed it on a real site. We had a look at the dev loop, components, custom components, state management, and how persistence and side effects work. We also looked at really nice quality of life features like built-in 3LO. Finally, let's touch on some of the directions we can take Forge UI in. We have a very focused set of components at the moment, and we're willing to iterate on this set of components based on the types of things that you want to build. We also want to make these apps coupled tightly to the product in the sense that when you're building an app, you should be able to tell the product, hey, pop a flag when the user does this, or these other kinds of things, so you can tell the product to do things on your behalf. And even further down the line, we think there are many candidates for showing Forge UI inside our products. This is still a very future state, and if editor macros go really well, I think there's a few good spots that we could see Forge UI cropping up. So to tie a bow around this, the main takeaways I want you to have are that building Forge UI apps they're simple. Even if it looks unfamiliar to you at this point, we had something running in a number of minutes. Also, I hope you're excited about editor macros. Whether you have an idea that could be a macro that's crucial to your team's workflow, or something that's just going to shave off an hour of a job you do every week. If you're curious to try Forge UI, we're running workshops or labs upstairs. I was in the labs most of yesterday, and I'll be there this afternoon. It is in a very early stages of development, and this is a great opportunity for you to tell us what you want. I'm confident that with that feedback and a lot of elbow grease from us, we can build the tool that makes you super productive. We can build that framework that does knock your socks off, And most importantly, we can create something that makes magic moments for our customers. Thank you very much.